Ah,
Anyway, welcome everybody to April 5th edition of the Denver Erlang Elixir. So, I did press the record button, and we're putting this little disclaimer up this time just to let everyone know that we are going to be recording these and we would like to start posting them on YouTube. So happy to discuss the merits if people hate that, but we just wanted to warn you
can I
that, hey, we're
ask a
going to the
question
internet.
about that?
You sure can.
Is it going to be just the talks or is it going to be like the whole meeting?
I was gonna put the whole meeting, but I am open to either one. So if people have strong feelings, I can just do the talks. But either way, right now I'm recording what we're saying. So we can decide what goes up where. Fair?
And I don't have an opinion. I was just trying to get clarification for folks. So
Sure. Yes. We will
Yeah.
not record the private chats, but Q&A, for example, those we probably will, just because it could be
Yeah.
useful. Okay.
Cool.
Back to the program. Oh, okay. There we are. So what do we usually do here? I have a few announcements. This time, excitingly enough, we actually have two talks. So usually we have a beginner's talk, a main talk, an opportunity for people to do a little show and tell, and then an online social breakout where we break out into different Zoom rooms. I'll go into those in more detail. So who are we? Hi, I'm Brett. I am one of the facilitators. We also have Jeff, Jeffrey, and I believe Alexandra on the call. And I don't know that Dylan was able to make it, but these are our lovely mug shots. We're the people that help make this thing happen every month. How do you get a hold of us? Well, we announce all of our meetings on meetup.com. We have a presence on the Elixir Slack channel, but that's basically a redirect to our own Denver Beam Slack channel, which sticks around a lot longer, where we allow discussions, sharing job opportunities, people looking, people chatting. It's primarily for the local community. So that's probably the best way to reach us, but you can also message us on Meetup if you so desire. All right, so each month we ask a couple of questions because one of the facilities that we offer with our meetup is a little networking here. So is there anyone currently hiring an Elixir Erlang developer?
Blinker is
Yeah,
hiring.
let's go for it, Saul. Sorry.
Blinker is hiring. Get a chance to come work with Alexandra and I. If anyone's interested, hit us up.
Okay. We in our Slack, we do have a jobs channel with more information. So I believe you may have Blinker may already be in there, but if not, you want to make sure there's a link to job listings. Anyone else hiring?
Yeah, community.com is hiring. We're looking for a senior Elixir developer or either senior or principal level Python developer. If anybody's got anybody that I'll post both of those in the link, and I'm more than happy to answer questions in the Slack channel as well. Thanks.
Cool. All right. Third time. Anybody else? No. Oh, I heard somebody.
Erlang Solutions is also hiring. Right now, I'm part of the Americas team, and well, we are looking for Elixir developers right now. But they can be Elixir Erlang developers, and they can be all around the American continent. It can be Canada, the US, South America, Mexico, or Central America.
Covers the bases. Awesome.
Mm-hmm.
Okay.
Since I don't see Angel here, I'll speak up. I'm a contractor working for cars.com. Angel is one of their employees, but they're hiring for several positions. I can look up the link and put it in the jobs channel.
That'd be awesome. Thank you, Brent. Anybody else? It's good. Good crop. All right. The other side of the coin, anybody looking for a beam related position? If so,
I used to be
Oh.
looking. I'll just throw this in here. Like today was my first day at BlockFi, so
oh,
Woohoo!
congratulations.
that's
Nice,
why
man.
I'm drinking.
Congrats, Mark.
Congrats.
That's awesome.
So I was looking, but not anymore. So it's been great.
All right.
That's great.
Congratulations.
Really glad to hear that. Congratulations.
Thank you.
Yeah.
I'm looking, but this is my first exposure to Elixir, so
Okay.
No, just
bar
keep
is
at
low.
it. That's
New-
my suggestion is just keep at it. It took me a long time, but I finally made it. So
Yes, newbies are more than welcome. So welcome.
How newbie is it tolerated? I mean, I haven't started picking up Erlang yet. I'm planning to use Joe Armstrong's famous book, Programming Erlang, but how long would it take for a newbie to even consider being a newbie? I'm guessing around
Ooh.
3 months.
I don't even know that I'd want to put a number on that. You want to take a stab at that, Jeffrey?
Well, I'm trying to figure out the context here. Are we talking about coming from another language, and we're talking about trying to get hired into an Elixir position, or are we talking about just when do you stop being considered a newbie?
Hired position. So I'm a traditional C coder. I'm starting to pick up
Okay.
Haskell, but then I got interested in Erlang as well because of its outstanding concurrency model.
Yeah, got it. I think the biggest thing is so you mentioned Erlang. Your job wise, you're probably going to find the Elixir market is bigger. I think.
Yes. I would agree.
Yeah, and there are companies out there right now who, as long as you're actually like excited and interested, there are some that are willing to take experienced engineers from other languages and train them up. It's so in that context, like you actually don't technically need to have a lot of experience under your belt if you're already an experienced engineer, right? If you're coming in new, looking for your very first job, then you're in a position where you're gonna have to find a company that's actually open to pulling in juniors. And there are companies that are doing that, like Blinker. I don't know that they have anything open right now, but they definitely have pulled people out of boot camps and gotten them trained up. So it's just an issue. I think it just goes back to start learning and putting yourself out there and just looking.
Okay, thanks.
And networking. Yeah, absolutely. It is doable, but it's going, it's a little bit more of an uphill battle if you don't already have experience under your belt, but it is totally doable. Okay.
Yeah, for context, at Blinker, we are hiring upper, mid-level, and senior engineers, no matter whether you have Elixir experience or not.
There you go. And in fact, we are actually as well. I just can't remember if we're trying to target people coming from specific languages or not. That's why I didn't say that, but I'll make sure it's clear when I go post jobs in the Slack org. So
cool. There are jobs out there.
And also here, Francisco, I have experience 1.5 years of experience using Elixir. So yeah, somebody knows something, reach me out.
All right. Okay, moving on. So I also plug speakers. So fortunately, we actually have speakers lined up for I think the next 2 months, maybe even 3. But later this summer, our schedule is wide open. And I don't believe we have many beginners talks scheduled yet either. So if you are interested in trying your hand at speaking, working on something interesting. If you want to do beginner's talk, it's a great practice, great way to kind of get yourself out there, force you to learn something too. So if you're a new person and you want to say, hey, I'm interested in learning more about, I don't know, something simple like recursion, or maybe even just some fundamental tools like mix, builds, or something, you could teach yourself a little something and then share what you learned with the group. So there's opportunities out there. The bar is low, the community is friendly. If you're interested, please talk to one of the facilitators. Does anyone have any general announcements? No. Okay. Going a little more in depth here. So after we have our talks, we have the opportunity, we open the floor for people to share any projects that he or she's working on. So got a problem at work, got a question you're stuck on, been messing around with something cool that you wanted to share with people, whatever, there's an opportunity there. Most month people don't do anything, but we provide the opportunity because in years past, it's been fun. So it's available. And then after that, we finally wrap up with Zoom breakout rooms, which I think if you have the newest Zoom client, you should be able to pick your own room. So I'll set up a handful of rooms and then you can wander around like a cocktail party sort of thing. So it's not like being in person, but hey, it's better than not at all. So we're coping. All right, so who do we have up this month? So Don is going to dazzle us with list pattern matching and recursion, as I understand it, followed by Solomon telling us how we can offload our busy work to our compilers. And I will let them explain more what that actually means. So with that, I will stop sharing the staircase, hand it over to Don if you want to introduce yourself and what you're going to talk about.
Sure. I'm actually, we're a growing community. We kind of talked a little.
Uh-oh. Did we lose Don?
Yeah, it's not just you.
Okay, I'm like, it got really quiet there all of a sudden. Oh man, come back. We didn't mean, we scared him away. That's all right. I'll try to get him on Slack here.
Sorry about that technical glitch. Of course.
Welcome back.
Thank you. But what I was saying is that it's good to have that we have some new people today. We have a beginner's talk. Some desktop one. Here we go. Yeah, so I'm specifically going to talk about some Elixir stuff today, but yeah, definitely any topic. Phoenix, you know, there are a lot of stuff that people do in Elixir is obviously web type related, so that's always good to have. But like we introduced, I'm talking a little bit about lists today. So specifically, linked lists in Elixir. So I'm Don Barlow. I use he, him pronouns. And I'm at Don Barlow. The easiest way to reach me is on the Denver Elixir Slack. And I'm out of our on social media type stuff. So I'm going to cover 4 topics today. First of all, the linked list data structure as a whole. Constructing lists, so making lists, nothing. Destructing lists, so having items in a list that you want to get. And then once you have a collection of things, you generally want to do something with those, some sort of list processing. So first, linked list data structure. So linked lists are not arrays. So someone had mentioned they're coming from a C background, so they're, I'm sure, very familiar with what arrays are. But linked lists in Elixir are not those. So arrays in general are kind of packed sets of data where it's really easy to randomly access any of those elements in that array. So for instance, that third element that says I'm an array, you can directly index those and get to it pretty quickly. Linked lists, they're called con cells. So it's not an array, it looks more like this. So you have, each cell has a value and then a pointer to the next value. And then that one has a pointer to the next one and so on and so on. So for, we kind of talked about in the array example, like kind of how you got to that third element there, but how do you get to the nth cell of a list? Well, in general, you don't. Elixir processes lists a little bit differently. So instead what you do is you traverse the list. So you go to that first element, you kind of play like telephone, if I ever played that game. You go to the first one, you ask them where they're pointing to, then you get to the second element and you ask that one where you're pointing to and you kind of traverse all the way down the list. So since lists are set up like that with one kind of pointing to the next one, it's a linear operation to go through the whole list. And so they call that order of n complexity. So what that basically means is the larger the n, the larger how much longer it takes to kind of process that list. So a list that's roughly double the size of another list will take roughly double the amount of time to process. So kernel.length is implemented for lists. And so it has to traverse the whole list, every single one of them, to count up all the elements. So the longer that list is, the longer it takes to actually count all those elements, all those cells in that linked list. And then just like any data structure in Elixir, it's immutable. So immutable means that once it's declared, it cannot be mutated or changed. So we'll get into some specifics of what that means when you're making them, destructuring them and that kind of thing. But it has certain implications to that as well. So we'll talk about constructing lists. So there's a list literal inside of square brackets like that. And then it can be any type on the inside of those lists. Here I have some strings, an atom, a couple of integers. Empty list is just 2 square brackets with kind of nothing in between. There's a list concatenation with the ++ operator. So in this case, we have 2 lists, right? The 1, 2, 3 on the left, the 4, 5, 6 on the right. And when we combine those, we're making a whole new list out of those elements to make that full list. There's also list subtraction. So in this case, the 3 is found, so it pulls it out of that list. If there's something in that array, or I'm sorry, if there's something in that list that it can't find, it doesn't throw an error or anything like that. It just ignores it. And then there's also something called the cons_cell operator. So this was one thing that I struggled with when I was kind of newer to Elixir, was the name of this thing. So in a couple of sources, they do specifically name this operator, but it's kind of hard to find sometimes. That's called a cons_cell operator. And here you have head and tail. We'll kind of show how that stuff matches, but those are just arbitrary variable names. They could be anything. Sometimes people use H and T, sometimes use head and tail, that kind of thing. So what that looks like here, so we have a list 1, 2, 3. And so what I can do is I can prepend that 0 in front of that list. And so it takes that front element and makes a whole new list. That existing list, that 1, 2, 3, still stays valid, but prepending to that list works and it's a whole new list. But prepending in general is fast because what I can do is just have that value, and then I can just make my pointer and say, hey, since that first list 1, 2, 3 is immutable, I can just point to the rest of it, and it can kind of share that tail space. And then a list literal syntax is actually the equivalent of writing a cons of all those things together. So 1, 2, 3, 4 is actually 1, cons 2, cons 3, cons 4. And if you notice at the end, there's an empty list that 4 is cons 2 at the end. So they call that an implied tail. So if you have just one element in a list, that implicitly means 1 with the cons of an empty list at the end. So what happens if you do this? 2 is not a list, right? So what happens? They call that an improper list. An improper list just means that the last element of a list is not a list itself. So it's kind of an edge case that, as a beginner especially, you don't really need to worry about, but just be cognizant of sometimes there's edge cases that will come up. So at least I've kind of heard that before. And then improper lists, in my opinion, are proper. Don't use them. For the most, like I said, there's kind of some edge cases, but for the most part, don't use it. Just use regular lists. I kind of mentioned before, prepending to a list is fast. Like I said, because we can just take that value and point to the rest of the list at the end. Appending to a list is slow because I have to traverse that whole list, build up a whole new list, and then throw another entry at the end. So that's a much longer in general operation to do. Sometimes when you get your data, it's in the opposite direction of what you need. So sometimes what I've seen is a trick is you just build it up in the order you get it, and then you flip it at the end when you're done with it. Okay, now we're going to talk about destructuring lists. So you also use that cons_cell operator to destructure lists. So for instance, I have a list 1, 2, 3, 4 on the right. So in this case, that head matches just that first element. and then the tail matches everything else left on the list. So that's another thing that kind of confused me early on with Elixir, was you have this one notation to both make and destructure lists. You can also match multiple head values. So in this case, I have an H1 and an H2 that matches on the 1 and the 2. And then the tail in this case is just the 3, 4 of what's left over. You can even match all the values. So in this case, there's 3 items on the right, and then I match them to 3 items on the left, the H1, 2, and 3. So what happens if you do this? It's not going to match. So if you try to match all the elements, you need to have the exact same size of lists so that it'll match. So kernel.head and tail, HD and TL, because vowels are expensive apparently, are similar to that cons, but they're just built in because sometimes you only want the head of a list. And so there's a head function that will do that. But they're both really fast, order 1 constant time, because they just have to read their one value. They just have to read that either that value or the pointer to the rest of the list. It's really, really fast to do those. Okay, so like I said, once again, you have a bunch of lists, you've built them up, you'll use pattern matching to pull some elements out, but generally if you have a collection of things, you want to do something with that collection. Filter them, pull some things out, reduce them to a single value, or transform that list into a different kind of list, things like that.
Hey, Don.
Yeah.
I'm kind of new here. Is it not, do you usually hold off questions till the end, or what's the situation?
No, feel free, go right ahead.
Oh, I had one question about, you said it was like linear consistent time complexity for getting the tail of the list.
Yeah.
How does that work? Is it like reverse it and then grab it, or how? I would have thought it still has to like go through all the links.
So if you remember, the head is just that first element, right?
Right.
And the tail, and so it has the element, the value, and then it has a pointer to the tail. The tail is every single thing that's left in that list, that whole other chain that's behind it.
Oh, of course. I thought you meant,
so
totally.
It's just the pointer to how many other elements are left in that list.
No,
right?
I think the misunderstanding was he thought you were saying you could get it to the last value of the list.
Right.
Yeah.
Right.
Cool.
Yeah, and that's, like I said, and that's something definitely that to be cognizant of. In general, when you're kind of doing things with like this, there's the head, and then everything else is the tail. And sometimes you'll, like I showed you, match a couple of elements off that head, but for the most part, you don't care about the rest of the list yet. I'm going to get to it later while I'm processing that list.
Yeah, totally. Thanks.
Mm-hmm. So yeah, kind of what I was talking about a little bit. So going through that list. So how do you go through those? Obviously, it's a functional language, use functions. There are no looping constructs in Elixir. There's no while loop, there's no for loop. So people coming from different languages might be surprised by that, but that's how that works. So I already talked a little bit about the kernel module. It has, that's where those plus and minus operators are defined, head, tail, and things like that. There's also a list module that has a bunch of functions in there as well. The enum module is also invaluable. I call it your new best friend. There's a lot in there, but the better you know that stuff, the better off you're going to be for sure. Specifically, map, reduce, 2 and 3 functions get used a lot. And then we're going to go over some of those concepts of these things as well, to how those work underneath the hood. There's also a list Erlang module that some of the Elixir list module calls kind of underneath the hood, but then there's it's good to kind of look to see somebody else who kind of talk about the beam in general or Erlang. It's once you have some of these concepts, you can look at some of those modules in Erlang, and they make a lot more sense to you because you understand the concepts, and maybe you can pick out some of those specific details. And then also, like I said, we can use recursion to process lists. So recursion simply means that a function calls itself. So that's it recurs basically. So here's an example. So we have a list of values that we want to reduce down to a single value. That's where the term reduce kind of comes from. And so if you see in that first method, I'm going to pattern match on that list. It's going to pull off the first element. In this case, we have that list on the bottom, 1, 2, 3, 4. So it's going to pull off 1. And then the tail is 2, 3, 4 as a list. And I'm saying head.sum. So I'm calling the same function name of the function that I'm inside of. So I'm saying sum the rest of the elements in the tail. So what that's going to do is keep calling itself until it gets down, and eventually will match that second function definition of that empty list. Like I showed you before, those lists have a implied empty tail. So eventually I'm going to say just add 0, but I'm not calling myself again. So it's just going to pop up the stack and start adding that 4, add that 3, add that 2, add that 1 to get 10. So when do you use recursion? So in general, that's why I said enum's kind of your new best friend. I suggest using the built-in modules, and only use recursion when it makes your code more expressive and easier to understand. What happened is, as they're building up this language, they kind of saw patterns, and they just said, hey, let's build these straight into the modules so that people don't have to write the same separate function heads and things like that over and over again. Kind of saves you typing and saves you work. But it's good to understand kind of how that stuff works under the hood. So we're going to look at some code. You guys still see my screen? Yeah. Okay.
We see it.
Yep.
All right.
Does Erlang support tail recursion optimization?
Yes, sure does. So I'm once again, it's kind of
the font size.
Oh, increase it, sure. Better. Better. That'll work. Is that okay, Daya?
Yeah. Yes.
Okay. All right. So once again, it's kind of a beginner level talk. So some things I'm really glossing over pretty high level. I'm not necessarily going into that, but definitely if that's something you're interested in, that's it for sure is implemented that way. So here's I have a list. It's actually a list of lists. So I call it a nest list converter. So it has RGB values as integers, and I want to convert those to a bunch of hex digits for whatever reason. So there's kind of a couple of ways to do that. One is, so I can just use that built-in enum.map. So I am using an anonymous function to match those values, and then I pull out, so I'm matching the whole RGB list, but then I'm also matching each one of those red, green, blue values individual in that list. And I have a little utility that just converts those RGB values to hex values. So underneath the hood, kind of what we were just talking about, is underneath the hood, what that map does is something like this, where it runs that with recursion. So it'll call that convert each. Like I said, recursion simply means that it calls itself inside of its method. So it first matches that first value on the list, and then I'm using the cons operator to, it just transfers the first value, and I'm saying prepend that to the convert each of the rest of the tail. So once again, it'll go through, keep on doing that all the way down. Eventually it's going to hit on the empty list at the end of the tail. And then it's an empty list, and then it's just going to cons that list all the way up to build it up. So let me nested. So if I run it with the map, I get that list of hex values, or if I run it with recursion, I get the same list. It's just two different ways of doing the same thing. Is it better or worse or not to use the enum.map versus my own recursion? It's debatable, right? So it's just kind of two different ways of doing the same thing. So lists, like I said, sometimes you're not necessarily in charge of how your data comes in. It comes in a different order, so another thing sometimes would happen, once again, just completely kind of made up case where I have these RGB values, but instead of them coming in nested lists, theirs coming in one big list, one big continuous list. But every third one is a red value, every third one is a green value, every third one is a blue value. So, because I was trying to think of, ways of, when would I want to use recursion? So this was kind of the example that came up with my head. But then actually, as I went implement the code, I'm just like, oh no, enum, my best friend, right? It's got this chunk every. So it will take every 3 of those items in that list and do the exact same thing that we had in that nested list. So I can still run the same map. I'm just chunking every. So it'll make a new list of 3 elements for every 3 that it finds in that original RGB data list. But once again, you can do that with recursion. So here, like I said, you can match those 3 head values on that list. So I'm just saying, hey, match the first 3, red, green, blue, and then the tail, but I'm still building up that list in the same way where I convert those first set of values and I say, hey, cons this onto the convert each of whatever else is in the list. And then when that function calls itself again, it'll go through eventually hitting that empty list and then build that list all the way back up. So similarly, with chunk, so the chunk or recursion, it does the same, pretty much the same stuff. So that's kind of what I had for code. Once again, I want to kind of keep this high level, light, especially being a beginner type talk. Lists implement the collectible and enumerable protocols. They're used obviously heavily by the enum module, but definitely that whole space in terms of list is very important. Comprehensions, list comprehensions, which I'm not going to go into too much today. I was going to kind of show you this. This is kind of in general what they look like. You're kind of building up a list and processing it at the same time, very similar to a lot of the code and things we've talked about. A lot of times as a Phoenix programmer, you'll see you have a table view or something like that, and you're doing individual rows for the individual elements. So you'll do a for in those as well to kind of, process that list and spit out rows inside that table. That's pretty much all I had as far as going over that stuff. So yeah, if there's any other questions, for sure.
Is there any, quick question, is there any performance difference between the map versus the recursion?
If there's any, it's going to be negligible. So underneath the hood, that's exactly what Elixir and Erlang, the Beam is doing underneath. It's doing that tail call, recursion to call itself. It's not adding a stack frame any bigger. It's optimized to just, it knows it's calling itself. And so at the end, it figures out that value and then computes all the other intermediate values on the way up to your return value.
I've got I apologize. Okay. I'm someone who has had extremely little exposure to Elixir or Erlang. For the protocols, I don't know if you used Java before, but is that sort of like interfaces?
Similar, yes, where you can define how exactly like an interface or methods that should exist for certain types, and then later you can implement those things for those certain types. So it's a very analogous kind of thing.
Sweet, thank you.
Mm-hmm.
So what is your experience with data structures and algorithms in Erlang? I mean, computer programming websites usually don't support Erlang or Elixir just yet, usually. I guess Codeforces does, but Erlang especially, they don't really support it. What is your experience with doing projects that are data structures and algorithms intensive in Erlang?
Very well suited. That's, it's in general. Mark, I think, just kind of said he got a new job. In general, a lot of the Elixir jobs were kind of quote unquote back-end engineering jobs, dealing with the data structures and everything on the back end. I in particular kind of do more full stack development with live view, so I do a lot of stuff on the front end and that kind of stuff too. But it's Elixir Erlang is very well suited to those kinds of tasks, for sure.
Okay.
Let's see, Mike I think I'm trying to understand. So you mentioned that the list is not an array. So even though I think Jeff just helped me understand that Erlang does support array, any reason why Elixir does not have array? Or just trying to understand that.
That I do not know, other than arrays in general in most modern type languages allow you to mutate those. So either change elements within the array or add items to that array, or push pop things, implement them as queues and things like that. Since Elixir Erlang is they're immutable data structures, there's just it doesn't fit that paradigm as well. Tuples are kind of similar to arrays that I would say are more used, but people aren't using, like, I shouldn't say people aren't, but in general, people don't use tuples for large data sets and things like that. They'll generally use more list processing, because then you can also stream those lists and do other things like that to not have your memory get too big as well.
Right. So if the immutability was a concern, then how is Erlang managing to support arrays? Are arrays in Erlang mutable then?
I'm not too familiar with Erlang arrays, so I would have to definitely look into that a little bit more and what exactly it is that how that thing, because I've definitely used Erlang queues before, which is, like I said, that's something that people in different languages, it's implemented as an array underneath the hood. I didn't necessarily look too much in the details of how it was implemented, but more kind of how it's used. So that's it's interesting. Like I said, the paradigm of list in a functional language kind of goes hand in hand. And actually, even kind of what I talked about with cons is dates back from Lisp in the 50s or whatever, like, cons and cdr of how you the first element and make elements of a list and pull elements out of a list. So
okay.
So yeah, I'll definitely look more.
Right. So in one place in your code, and this is kind of pretty new to me, was that you were doing a RGB like a pattern match on the 3 elements of the list, and that was in the function argument definition. You were doing a pattern match over there. I don't understand. And then you were ignoring the RGB variable itself. I didn't quite understand that part. Like, if you could share the screen,
oh yeah, sure.
It'll make sense.
Back to that.
Right.
So
yeah,
right here in my anonymous function,
yeah,
I didn't
that one.
Yeah, I didn't necessarily have to. I just kind of was more trying to show that because normally a map in your function, your anonymous function takes one value and then has a method body inside of that, or function body inside of that. So I could have left that off for sure. I just did this just as more of an explicit way of saying, hey, I'm matching this RGB struct, but it really is a list of 3 items.
Right, because chunk every will just send you the list of 3 all the time.
Right. So this is what comes out at chunk 3. So that's probably redundant. I did it more for just to make for readability purposes. It's not needed by any means. Nope.
Right. Okay. All right. Thanks. I was just like, what is that? Okay. Thanks. Yeah.
Sure.
I'm interested in designing a foreign functional interface to the Erlang virtual machine zone language. We already have an Erlang package in Haskell, but not for the actual virtual machine instruction set, the Beam virtual machine. Do you have an experience manipulating with the Beam virtual machine? Easy to follow?
I don't specifically. You can call, when I mentioned too, anything in Erlang, you can call directly from Elixir. The syntax for that it's actually in my presentation there, wherever that was. There we go. Is to use that colon Erlang module name. So underneath the hood, all Elixir modules have an uppercase Erlang dot something, whatever that module name is. So this is a way of accessing those Erlang modules underneath the hood. So that's one thing. Once you have something that compiles down and runs on the beam, calling one thing from another, it's running on the same virtual machine. So it's definitely available to do for sure.
Mm-hmm. All right, any final questions for Don?
Yeah, since we are on the topic of the list and the arrays, Sam, you I think wrote about the literal syntax being used for pattern matching. I quite couldn't understand that. Can anybody please expound on that?
For
in the chat window.
Oh, in the chat.
Sam talks about answer from Jose Volim about why arrays literal syntax was not supported. I don't want to understand that. Can anybody please help me understand?
Yeah, I can speak to that. So when you actually create an array in Erlang, you're calling a function that returns that data structure, but there's no actual, you know how a list is square brackets with, comma separated values inside. There's no actual, that's a literal description of a list, right? There's no literal description of an array. So because there's no literal description of array, you can't create a pattern off of it. Does that make sense?
Oh, okay.
Yeah, it's like weirdly more simple than you'd expect. Yeah, like there's not an actual visual representation of array. It's a data structure that gets bound to a variable and then manipulated with functions, right?
Right, but because you can't do pattern matching with that, you just like ignore the whole array thing. But
well, they're also built differently. Listen, they're built differently as well. I think it was Michael pointed out that they're actually under the hood a tree. Like I'm not sure what the problem is. Like ultimately, stop trying to bring your experience with arrays from other languages into here, and just trust us that just think of as a list as basically how you've always thought of an array, and it's not really going to bite you.
Right. Okay. Okay, cool. Interesting.
Don, what can you explain a little bit what those optimization tail means, please?
So in a stack, when you have a function that calls a function, you're now 2 deep into a stack frame. And then if that function calls another function, you're now 3 deep, right? And so on and so on. But with recursion, since you're calling the same function, it can do some optimizations. So it doesn't make a arbitrarily, my lists weren't very long in those examples, but say I had a list of 10,000 things. I don't have to have a stack frame of 10,000 method calls or function calls, one inside of another. It knows that I'm calling the same function. So there's optimizations that will just compute that tail call, that last value, and then compute all the other values going the way back up. Does that make sense?
Yeah. The question is because in the book Programming Elixir by Dave Thomas, he explained that in order to achieve optimization, tail optimization, the last call of the function should be the same call.
Yes.
The same function.
That's correct. Yes, I did not point that out, but that is true.
Okay, that's it.
So since we're missing iteration in functional programming languages, we have to rely on recursion instead. And basically, I wanted to talk about tail recursion because that's one of the ways you can hopefully make it use less memory, if not make it faster, as someone pointed out. And the second option to hopefully make your program run a little faster is dynamic programming. How's dynamic programming in Erlang and Elixir compared to other functional programming languages like Haskell and Lisp?
Since it's not a typed language, it's dynamic-ish, right? So it's not like Ruby where everything's an object and duck typed and things like that. But you can pattern match. So if you have structs that look similar, and I can pass in just a map that looks enough like that struct that pattern matches some of those function calls, I can go ahead and use those functions. So it really, there's definitely a lot of flexibility in Elixir and in Erlang and how it does that pattern matching. It's not strictly type-based. People are making Gleam. There's actually, I'm not sure how long, a few months ago, somebody gave a talk on Gleam. So somebody is trying to make a strongly typed language that sits on top of the beam as well, called GLEAM, Gleam. So it's kind of another approach. And actually, there's actually a few other languages as well being built on top of the beam. But as far as, I guess it really kind of depends what you want to do. I think I came from Ruby. There's quite a few people from in the Elixir community now, including Jose himself, that came from that community. So he wasn't necessarily willing to give up a lot of that dynamic type programming stuff to be locked down with strongly specified types everywhere and things like that. So I don't know if that answers your question, but that's kind of the spirit of the language of why it was created.
And it's both a blessing and a curse, but if you're used to strongly typed, it's definitely, or statically typed languages, it definitely can be one of the pain points of learning and switching over.
So how is Erlang revolutionized the way all of you do your projects? Erlang/Elixir, either one. What has it Erlang Elixir taught you the other languages come out besides concurrency? Because Erlang, of course, is famous for that.
Yeah, so that in itself is really, I mean, that's huge, right? But so yeah, we've got actor model concurrency. And in fact, like, I mean, honestly, it's a lot of it is that we've got an easy to read syntax. By the way, we should be looking at capping this conversation shortly. Like, this is, and it's not that I want to discourage any of this enthusiasm, but I think we need to figure out a better way to encourage it and address those questions. Because Don was signing up to give us a beginner track talk.
He's done great.
Yeah, he's done a fantastic. So here's the deal: is that it's easy to read syntax. Like, it's if we can agree that Ruby has clean readable syntax, Erlang has, or sorry, Elixir, not Erlang, but Elixir has a pretty nice syntax on top of that. The actor model concurrency gives us a whole lot, combined with the immutability of the data, gives us a really strong concurrency model, and that is really, really well suited to web server work, right? Being able to handle multiple requests. I mean, for just an example, so you said besides the concurrency, I mean, we pattern matching, like we've got the with statement, which is something that is basically like a railway programming where you can actually cut short as soon as one of your conditions stops. You go in a line of conditions, and then as soon as one doesn't work, you drop into resolution instead. So there's a lot of like really nice things around it, but the fundamental draw of this stuff, and the reason why all this stuff has been built on top of the Erlang beam, is specifically because it's got a really, really nice concurrency model.
Okay, thanks.
And that's very solid. All right, I'm going to wrap it up here. So thanks for all the questions. Yeah, we can talk later about a different forum, but it is good to have conversations about people coming to the language too. So I didn't want to squash that, but a lot of them are not beginner track at all. So they're quite advanced topics, but they're great questions.
The purpose is we're a growing ecosystem. So you have a lot of people learning, and people are maybe starting out fresh, I've been a whatever developer for a long time, that kind of thing. So, it's definitely, somewhat on task that we're trying to, in general, growing. We're all excited. Obviously, we're spending our Monday nights coming to a meetup like this. And there's a reason for that. And Jeffrey kind of hit on it for sure. That's a big part of that.
But the developer environment too, like the tool sets we have, the language was created, it's relatively new, and it was very focused on creating a positive and a really good developer experience as well, right? And so it's got a really good test framework built into the language itself that doesn't really require much extension to be able to do just about everything you need to be able to do. It's got the build tools are pretty nice for it. Admittedly, the one place, and it's just because of the way the virtual machine works, that's a little wonky, is actually changing the behavior of a compiled application based off of environment variables. But that's being worked on and solved. But just about everything else about it is actually just pleasant to work with in a way that you don't typically get that much consistently across the board on the tooling around a language as well. So this is a great conversation for us to pick up in the Slack channel as well, so there can be a continuing conversation, because I really don't want to discourage your interest.
That's a great suggestion. Thanks, Jeffrey. Yeah. Cool. All right. Yes, being cognizant of time, and we don't want to keep everyone here all night. Let's switch gears, and I'll hand it over to Solomon, who is going to talk. Well, I'll let you introduce what you're going to talk about, because I wasn't exactly sure what you ended up on. So it's all yours. And we see your test pattern over.
All right, cool. Awesome. Cool. So I'm going to talk about offloading your busy work to a compiler. And here's what I mean by that. So first of all, I'd like to ask the question, why do people use computers? So there are, some pure entertainment reasons that people might do that, for gaming or for Netflix or communication with other people. I'd like to mostly talk about automation and automating repetitive tasks. Computers are obviously very good and very fast and very consistent at automating tasks. And keep in mind that programmers are also people using computers. So it's a little bit meta. We're building tools for other people to automate their repetitive tasks, but we have repetitive tasks of our own. And so we often use tools to do that. And one of the common tools that we use is a compiler. So I looked up the definition of a compiler, and the official definition of a compiler was, something high-level language, something machine code, running on a processor. And, right away that already excludes the Elixir compiler, because the Elixir compiler translates Elixir code into Beam code, which is then interpreted by the Erlang virtual machine. So I think we need to broaden our definition a little bit. And so in our context, I'm going to say that a compiler is a tool that translates the code that I want to write into the code that I don't want to write, because I don't want to be writing Beam code by hand. That would be very tedious and error prone, and probably not many people on the call do either. So to kind of set the stage for what I'm talking about, I'm going to have to introduce a contrived example. So welcome to contrive.com. We are a company that does math as a service. And so our first product is actually going to be division over GraphQL. So our schema looks something like this. You can send in a divide by query. You can send in a couple of numbers. We will divide those numbers and give you back the answer. So we have a couple of integer inputs, and we return a float output, and things are hunky-dory, right? Well, let's take a look at maybe an implementation of what this might look like in Elixir. So here's our module. We've got a function in here to do our division. We take a dividend and a divisor. We divide those and we return the result to you. What could possibly go wrong? Astute viewers probably realize that, unless you're this guy, then dividing by 0 is going to be a problem for you. So we need to protect against that. So let's go back to our schema. And let's say that our query actually returns a union type, which is either a float or an error. So we've got this enum value for our errors. And if you pass in a 0, we're going to return the not Chuck error. And otherwise, we're going to continue on as previously scheduled. So let's update our implementation here. So we define a module called not Chuck. It's an exception module, and we add a guard function here that detects if you're passing in 0. And in that case, we return you back this nice error, and GraphQL will translate that to this enum value, and everyone's happy. The front end's happy, the consumers are happy. They get an actionable error message. This works really well. And then our product team comes along and says, that works so well that we have introduced a new constraint. We're actually not going to let people divide by even numbers either. So whenever someone tries to divide by an even number, you need to return a can't even exception. And so this is, coincidentally enough, this is the face that you make when you're given this new requirement. But then you go ahead and say, okay, well, that's fine. We'll go ahead and we'll do that implementation. So we write some tests. We add a new guard function in here that checks to see if the remainder of the divisor is 2 by 2 is 0. And if that's the case, we return our new error struct here, or our error enum value, and everything is great, except we forgot to implement our, we forgot to add our new value to the enum. So our tests, our unit tests are going to pass. Hopefully we have some integration tests that would catch this, but that's not the best way to catch this kind of thing. And besides that, even if we do catch this with a test, this feels like bookkeeping, and I'm lazy, and this feels like something that a computer should be doing for me. It should be able to see that I am producing these values that are going to be used as return errors to a user, and it should generate this enum for me. I shouldn't have to edit code over here and then come over here and edit more code just to make that happen. So how could we do something like this? Okay, so that's the contrived part of the talk. So now let's talk about, if we had this situation, how could we potentially go through our code and generate this kind of error enum automatically? We talked a little bit about, similarities to Ruby. There's a strong crossover from the Ruby community and Elixir. In Ruby, you might do something like runtime introspection, where you're looking for, where are all the ancestors of a certain module, or as you import a certain module, you might register yourself as an error enum value and then spit those out. Typically in Elixir, we want to do something that's more compile time. Elixir has a pretty robust macro system, so we can do things at compile time and preload a lot of that work for us. So if you've poked around in a Elixir project, you've probably seen beam files. So kind of buried under some arcane directory structure somewhere, there are a set of .beam files, and those are the compiled versions of your modules. So if you do something like path.wildcard, you'll see a bunch of beam files spit out. These are kind of buried in different places. Where they are does make sense, but you probably shouldn't be just hard coding a path in there and looking for beam files that are sitting in a certain spot. You'll notice that these are prefixed with dev. So these are for the dev environment. If you would rerun in production, it's going to be a different path. So is there a way that we can look for where our beam files are and have the running system know where that is? And the answer is yes. So there's a function called CodeGetPath. So if we take a look at that, it returns the code path, which is very helpful. So what that means is, for whatever environment that we're running in, code.getPath will tell us where all beam files can live. So let's do that. Let's run CodeGetPath. By the way, kind of tying into the previous presentation, code is an Erlang module, so we can call it directly without any kind of foreign function interface or anything like that. It's directly callable from Elixir. So if we call CodeGetPath, again, we've got several paths. Some of them are my Elixir installation. Some of them are, Erlang paths. But if we were to do something like this, code get path, and then flat map that. Basically, I want to just take each one of those paths that are in the list and stick a /.beam on the end of it. And then I want to feed that through path.wildcard. Okay, so now I have every beam file that my system knows about. So how could I look through these and find which ones of these are these custom errors that we want to get out and put into this enum value? Well, let's do a quick filter first. We know that our module name was not Chuck. Okay, so here's where it is. Kind of the first idea that we have is, we could look for this specific structure of module, but that feels a little bit brittle. If we change our naming convention, we're probably going to have to change whatever mechanism we're using to pull these out. So what's another idea that we could use? What I really want is I want to kind of annotate this module and say, this specific module is one of these enum values and these others are not. So what about if we added an attribute? Is there a way that we could read attributes that are in a module? And the answer is yes. There is a function called beamlib chunks, again, another Erlang function that's built in. If you pass a beam path to this function and ask it to read the attributes, then it will read the model attributes for you and spit those out. So let's take a look at what we might be able to do. So the idea is to make our error enum module look something like this. We'll add this GraphQL true module attribute. It'll still be an exception, and hopefully that will work. So let's try this out. If we call beamlib chunks, we have to pass this as a character list, not as a binary, because it's an Erlang thing. That's fairly typical. And we want to read the attributes specifically. Well, we got our module back and we got some attributes, but there's nothing in here about GraphQL being an attribute of this module. Well, as it turns out, Elixir attributes are just that. They are Elixir attributes only. They go away when they're compiled and they do not exist in the beam. And in fact, if you would look at a cold compile of this application, you'd notice a warning that I'm setting a module attribute here and then I'm never consuming it anywhere. Sorry?
My sense is somebody's just got a hot mic.
Ah, okay, no worries. Okay, so is there a way to get around this? And the answer is yes, there is. If we registered that we are going to create this attribute first, and we ask the beam to persist that attribute for us, then that attribute will stick around and it will still be present in the beam. So let's take a look at that with our not Chuck module instead of our add attribute. Cool, so that worked. So we have a GraphQL true attribute. So now it's just a matter of running through each of our beam files, pulling out the attribute values, filtering for modules that have this attribute set, and then transforming this module name back into our enum value. And then we'll have something that we can register as an error enum value. Okay, so our implementation now looks like this. We have our module. We register this attribute and tell it we want it to persist even when it's compiled into a Beam file. We actually define the attribute. It's still an exception. And then once our compiler runs, which we'll talk about in a minute, we'll get something like this as the compiler output. Okay, so the only thing that's left to do is to actually spit out this custom enum. So we use a secret weapon in the CodeGen toolbox, which is string interpolation. We basically build a string and then splat the enum values right into the middle of it and write that out to a file. Okay, cool. So once we have that working, we'll need to change our GraphQL schema to import our error enum from that generated file. And then the rest of our schema is the same. And to tie all of this together, we'll define a custom mix task. So if you define a mix task and this use mix task here is what makes it a mix task. The convention is to define kind of a top level and then a specific name. So we call this compile error enum. And I'm just going to leave this in pseudocode. You've kind of seen pieces of this already, so I won't spell it all out on this slide, but we're going to call our code get path to find out where all of our Beam files can be. We're going to send each Beam file through this beamlib chunks function. We're going to filter out everything except for those modules that have that GraphQL true attribute. We're going to do some basic string manipulation to change the module name from the Elixir camel case to the screaming snake case that GraphQL wants. And then we're going to splat that out into our template. And so everything is great. So we'll add in our mix.exs in our project, we'll add a key called compilers. And we'll say that we want to keep the normal set of mix compilers, which is going to compile leaks and YEC files, and then compile Elixir, and then compile Erlang in case you have any native Erlang files in your project. And after that is all done, we want to tack on our specific custom task so that we know that all of our Beam files are in place, and then our task can pick those up and then generate our error enum. Okay, so that's a perfect solution, right? Because we are adding 2 lines of code so we can save writing 1 line of code. So it's great. I would argue in a way it's still a win because we only need to update 1 place. But let's see if we can make that better. We've talked a little bit about macros in Elixir. So, all of this code here is basically going to be the same every time. So let's make a macro out of that. If we copy and paste this and put it in a quote block, we can make a GraphQL macro. We're going to change it up just a little bit. We're going to accept the default message that we want our error to have. And we're going to unquote that in as a default right here in the exception block. So that cleans up our code quite a bit. We can call our custom error just like this. We say use GraphQL error, pass in the default message, and then everything else works as expected. And that's it. That's how we offload our busy work to a compiler.
Cool.
Pretty awesome. Pretty good.
Yeah, Max and I can vouch that it works great.
That was actually, I was like, I don't want to doubt the speaker, but would you put it in production?
We do actually use this one in production, Jeffrey.
Oh, good. Good. After the last time you got me excited and then admitted it was more of a side thing. That's cool.
Yeah,
So,
definitely. It's one of those, I was gonna say, it's one of those things that you figure out, and then, you know, it takes you a while to kind of get that stack, but then once you have it, it's just like, it's so useful,
Yeah.
right? So you're like, oh, it was so worth it going through all that, right?
Yep.
So what's a more non-contrived or realistic example?
So that is actually a simplified real world example. We use it for exactly this. We're not doing math as a service, obviously, but we do have a number of like custom exceptions that we want to return. We actually break them up into recoverable versus non-recoverable exceptions. So is this something where the user fat fingered something and they should be able to fix it on their side if we give them a proper message? Or is this something like the server's down and on fire and there's really nothing that they can do? And so we just, you know, give them a message that says, please try again later. So we kind of incorporate that into the macro. We say use exception macro recoverable or use exception macro unrecoverable. We have some other options about like setting other fields besides just the messages and things like that. But it took a long enough time to go through the contrived example. I didn't want to bring out like actual work code and go through all of that.
Sure.
Awesome.
Cool. Well, thank you for that, Solomon. It was definitely a bit deep, but it looks like a very useful feature.
I have a quick question.
Sure.
Yeah, so looks like you're going through all the compiled Beam files, right, on the system.
Right.
So if you have like a bunch of projects, you're going through all the files and looking for the presence of that module attribute. Could you use like something like xrefs to like limit it to specific project?
It is project specific, so it's going to only be the project that you're running in. But yeah, you could probably like pre-filter code get paths if that for some reason was too big on your system. You know, if you had say you had an umbrella project and you knew that errors were going to be in a certain place, then sure, you could pre-filter paths down so that you're not looking through, you know, everywhere a beam could possibly be.
Cool.
Any other last questions for Solomon? Okay, then let's move on to show and tell time. So the opportunity to share with the group any code projects, questions that he or she might have. Might be interesting to others. All right. Not hearing any pressing desire to steal the mic, we'll move swiftly on to the happy hour section. So let's see here. We have 27 participants. That is crazy talk.